Hi, and welcome back from spring break. Before spring break, we took the week to review SOHCAHTOA and right triangle trigonometry. This week, we're going to be talking about just kind of an introduction to angles, so a little bit more about the angles themselves. And then we're also going to be getting into radians. One of our goals for this first part of the unit is to get into the unit circle, which is something we'll get towards to the end of this week and then next week as well. And then additionally, we'll be using the unit circle to graph trig functions such as sine and cosine, but that's not for another week or two. So today I'm just going to kind of introduce you into some of our vocab related to angles. So trigonometry is really just the study of triangles. And then an angle is found by rotating a ray about its endpoint. So oftentimes we call that endpoint the vertex. So I'm going to put my vertex right on the origin here. And then I have what's called the initial side. So this is the starting position. So I would put that along the x-axis. And then the terminal side is the ending position of the ray. So imagine if I took that ray along the x-axis and I rotated it to somewhere in that second quadrant. So I have my vertex, my initial side, and my terminal side. Now, the example that I just drew is considered an example in standard position. So this just means that the initial side is on the x-axis. And typically when we're drawing angles these next few days, that's how we are going to draw most of our angles in standard position. So that your initial side goes along the x-axis and then we rotate that terminal side about. Now, we have two different types of angles. We have positive angles and negative angles. Anytime you see counterclockwise rotation, that's considered a positive angle. So for example, the one that I drew before, or I can draw another one here. So let's say here's my initial side on that x-axis, and there's my terminal side. So because I'm rotating that ray counterclockwise, it's considered a positive angle. This is one of the most important reasons for why I draw that angle, that arrow actually inside my angle to show the direction of rotation. So then negative angles is going to be clockwise rotation. So for example, if I drew another angle, so my initial side is along the x-axis, and then let's say that I rotate that endpoint clockwise, that would be considered a negative angle. And then finally, we have quadrantal angles. So this is when your terminal side lies on the x or y axis. So for example, if we had just, let's say, a 90-degree angle, so I have my initial side, terminal side, and then that arrow in between to show our direction, that would be a quadrantal angle. You could also have 180 degrees, whether it be negative or positive, would be a quadrantal angle as well. So how do you know the measurement of an angle without using a protractor? A lot of times we're just going to be kind of estimating. So typically what I use is our quadrantal angles to kind of determine that. So we start off with 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then we're back at 360. So one complete rotation or circle. So I'll use this to kind of estimate. So let's say that I wanted to draw an angle of 195 degrees. Well, I know that that's going to be 15 degrees past 180. So if I put my endpoint or vertex at the origin, initial side goes along that x-axis, I want to go a little bit beyond 180 degrees. That would be an estimate of 195. Likewise, I could do the same thing for negative angles. So let's say we started off with 0, negative 90, negative 180, negative 270, and then negative 360. So if I wanted to draw an angle of negative 293 degrees, let's say. So my initial side still goes on that x-axis. Now it's going to rotate, not quite a full circle. So it's 23 degrees past negative 270, so to about right here. The next few examples are encouraging you to kind of figure out which quadrant or axis in which each angle's terminal side lies. So that's very similar to the previous examples. Just a refresher, so we have quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. So for example, 113 degrees, I know is going to be between 90 and 180, so that would be in quadrant 2. 345 degrees is between 270 and 360, so that would be in quadrant 4. I could do the same thing then for negative angles. So if this is negative 90, negative 180, negative 270, I know it's going to fall somewhere in quadrant 1. Same thing, these few examples below. So again, it's just asking you to sketch angles in standard position. I'm going to skip this for right now because I want to talk about coterminal angles. So a coterminal angle are angles that have the same initial and terminal side. So for example, I want you to picture if I had, let's say, a 20-degree angle. So here's my initial side. Here's about 20 degrees. If I took this terminal side and I rotated it all the way around to make one more complete circle, my actual angle would look the exact same. But instead of being 20 degrees, if I added that 360 degrees, it would be 380 degrees. So while drawing it, it might look slightly different just in the sense that when I drew my arrow inside, I would have one full rotation and then it would go up to 380, a little bit more. So here's 20 degrees and here is 380 degrees. So to find coterminal angles, what we are doing is we are adding or subtracting 360 degrees. So for example, if I want to find two coterminal angles, one positive and one negative for each angle. So if I had 56 degrees and I took 56 plus 360, I would end up with 416 degrees. Likewise, if I took 56 and I subtracted 360, I would end up with negative 355 degrees. Those angles would have the same terminal and initial side, but their measurement is actually different. Now, I just want to touch on really quickly the last example. So here it's a little bit more specific. So it says find the coterminal angle. This symbol here called theta is just in reference of an angle such that it's between 0 and 360 degrees. So for example, if I have 608 degrees, I want to figure out should I add 360 or subtract? Well, if I'm looking for an angle between 0 and 360, that means that this is too high. So I'm going to subtract 360 degrees. So if I take 608 minus 360, I end up with 248 degrees. Likewise, if I have negative 46 degrees, because it's negative and I want an angle that's between 0 and 360, I need to then add 360 degrees. So I end up with an angle of 314 degrees. Now, I want you to go back and take any more notes that you would need in order to really answer some practice problems. And that's all for now.